Hello everyone, my name is Sudhat, a third year BTech Engineering Physics student at IIT Roorkee. In this presentation, I'm going to talk about touch sensors. So first, I'm going to talk about introduction to touch sensors, what touch sensors really are, and what are the two popular types of touch sensors. Then I will be talking about the working of the touch sensors for both of the types. Then I will be talking about applications of touch sensors in our daily life, and then I will be discussing about touch sensors in smartphones. And after that, I will be talking about FTIR touchscreen technology, which is currently being researched. So every day we use a lot of portable electronic devices like smartphones, tablets, etc. We started from mobiles, which used buttons to interact, and now we are using a touchscreen to interact with the device. What enables us to use this touchscreen are touch sensors. So touch sensors basically captures and records physical touch, as the name suggests. It can act as a switch which turns on or off based on the contact. So we could say that the circuit is closed if we are touching the touch sensor. Now it is not necessary that the physical contact is required. Touch sensors could also be designed to capture proximity to a certain extent. Now, as the touch sensors are been replacing switch, so we could say that it reduces the overall cost of the system. Furthermore, it's more appealing to use touch-based devices. So touch sensors are more popularly categorized into two types, capacitive and resistive based touch sensors. Now, capacitive touch sensor measures through change in capacitance, uh, and resistive touch sensors measures through amount of pressure applied. Capacitive touch sensors are multi-touch capable and resistives are not multi-touch capable. Capacitive touch sensors could be used are used in smartphones and tablets. So we could say that capacitive touch sensors are dominating the market. Resistive touch sensors, on the other hand, are used in musical instrument or ATM machine. So let's understand how this touch sensors works. So we could say that as I said in previous slide, we could say that when touch sensor senses the touch or proximity, then it acts like a closed switch, otherwise it acts as an open switch. These sensors are also known as tactile sensors. Now, a capacitor consists of two conducting plates separated by some medium. Now, in case of capacitive touch sensors, there are two plates with uh, C naught as capacitance, and other plate is exposed to air. We could is exposed generally to air. So, when human touch is identified, then the touching part of the sensor is referred to as conducting object, and capacitance is denoted as CT, which we could see here. The C naught is monitored continuously by using measuring equipments. As the change in the capacitance is detected, it will be converted into some form of a signal. Resistive touch sensors, on the other hand, detects force or pressure applied. We could see here that there are two transparent electrode films. In one film, their electric current has been passed, and when we apply a force, then the other film gets distorted, and here a point of contact is been obtained. So the circuit is basically closed, and this point of contact is then getting detected. Coming to the applications of touch sensors are used in smartphones and tablets as previously discussed. Here capacitive touch sensors are used. In laptops, we could see touch sensors used in touchpads. Here also capacitive touch sensors are used. Touch sensors are also used in musical keyboards. So we could see that some keyboards are touch sensitive. So when it depending on how hard a key is pressed, the amplitude is varied. And in this, we could clearly see that since it depends on the pressure applied, so resistive touch sensors are used here. And in ATM machines, you could observe that sometimes you have to press hard uh, on the screen to for the screen to detect your touch. So here also resistive touch sensors are used. And now I will discuss about how touch sensors are used in smartphones. So, surface of a touch screen of smartphone is made up of electrically conducting material, such as indium tin oxide. Indium tin oxide is used because it is transparent in nature, and so when we touch touch this touch screen, then at the point of contact, certain amount of charge is getting collected. So it distorts the electric field, and this is detected by sensors which are present at the corners of this touch screen. And this information is then fed to a processor, and processor takes the appropriate action. So now it is not necessary for human hand to make the physical contact. We could also use device like stylus, and they are specifically designed for the convenient usage when we have to draw or take notes on touch-based devices. Currently, gloves are also being developed in such a way that their contact could also be detected by touch sensor. Now I'll be talking about FTIR touchscreen technology. So, having discussed about currently dominating touch sensors, I want to now talk about currently emerging touchscreen technology, and FTIR is one such touchscreen technology. So, FTIR phenomenon occurs when a light which is supposed to be totally internally reflected undergoes transmission and refraction. So, here in this setup, we could see that LED light which is emitting IR beams and which are getting totally internally reflected. But when a human finger touches this screen or plane, at that time, at the point of contact, this TIR is disturbed. The light is frustrated, causing it to scatter and reflect out of waveguide. And this scattered light is then detected from an camera which is placed beneath this. So, advantages of this FTIR touchscreen technology over the currently popular one is that it is that non-conductive touch can also be picked. So we could use gloves which aren't designed for touch screens. They can also be detected here, and it allows for simultaneous touch. So we could multiple touches can also be detected, and uh, in because of this FTIR technology, we could also design a immensely large touch screen. A disadvantage of this FTIR technology is that since this radiation must be detected, so we need a that IR camera to be situated far behind. So the size is very large, so it can't be used in portable devices. Furthermore, radiation from other IR sources creates background noise, so the touch is not properly processed due to that noise. Some amount of error is also there, always there. Thank you for watching this presentation.